Hello, today we're going to solve the problem of the day from LeetCode. In this problem, we receive a vector of numbers and also another parameter p. We need to find a way in which we can delete a subarray from the original array nums. And also, after deleting that subarray, we need to follow the condition that the sum of the remaining elements is divisible by p, by the value of p. To solve this problem, we can initially think in two ideas. The initial idea is that there is one property that is valid, and if we want, like, after the deleting operation, that the remaining array, the sum of the elements of the remaining array is divisible by p, that means that, for instance, let's say that if our current sum of all the elements of nums, let's suppose that these are the elements of nums, imagine that the sum of this mod p equals, let's say, x, then let's assume that the subarray that we're going to delete, let's call it b, and b will be like a sub e plus 1, and until a sub j. And we need to follow the condition that this remainder also needs to be x. In that way, if we subtract the initial elements of the array and we remove these elements, if we subtract the remainders, this will be that the remainders of the remaining elements, the sum of the remainder elements will have a remainder against p of 0, because we are subtracting the same value, and then in the left side we will have the remainder elements, like the remaining elements, and in the other side of the equation we will have 0, because we are subtracting the same number. Okay, that means that we need to find a subarray that follows this condition. And the main idea is, like, the initial idea that one can think is trying to apply directly brute force, like between any pair e, j, basically, and check if this condition is achieved. And if this condition is achieved, then we can, like, try to get the subarray with the shortest length. But that will be a complexity of n is n pod 2, because we are, for each value of e, we are traversing n elements, and for each value of j we are also traversing n elements in the worst case. For that reason, the complexity will be quadratic. But if we see the constraints of the problem, then it won't be possible to solve it, because usually a computer can perform between 10 to 8 operations per second. And with the current constraints, if we do brute force, that will mean that we will require this amount of operations in the worst case, and this won't pass. For that reason, we need to think in an idea that is more optimal, because otherwise we cannot solve the problem. And to do that, we can, like, try to think of the following. If we have our array nums like a1, a2, a3 in this way, we only need to find, like, a subarray that follows this property. But let's say that we use, like, an idea like we calculate the reminders for the prefixes of the array. That means that for instance, we could say, oh, I can calculate the remainder of the sum of the elements of this array, and then I calculate like the remainder of the sum of these elements, and then the remainder of the sum of these elements. And in that way I can have like the values already pre-computed for the prefixes of the original nums vector. Then only I need to find two, let's say, values or points which difference in, let's say, mod p is equal to this property. And if I store, like, for each of the prefixes arise the value of this property, then I can like do it faster, because for instance, let's assume that I am in the position j. I already know what is the sum and the mod p of all of the elements until j. And in the past, when I processed like an index for these indexes, I also already have this value. That means that, okay, I already know that, let's say that the remainder for this value is j, is this value. Then I only need to find a value e for like a previous index, which remainder against p will be this value, because then if I subtract these two values, I will get what I want, because I want that the sub array that I am going to delete has a remainder x, and if I subtract this and this, I will get that, and also I will find e and j in a more optimal way. Okay, I hope that it will be a bit more clear during the implementation, but let's start. Okay, we can start with an ordered map to store like let's assume that this operation of summing the vectors, the elements of the vector, and then finding the module against p, let's call it property. And for that reason, the unordered map will be called property prefix, let's say. But then also to begin, we need to find this value x that I am defining here. We need to find this value x. For that reason, we are going to find it before. Like, let's assume that that is total property, because it will be like the property for all of the elements of the nums vector. Also, then this will be total property. Also, it's important to know that if you want to calculate this, then this is equal to this plus this, and then again mod. Okay, with this part I have like the total property calculated for the complete nums. Then I am going to calculate the property for the prefixes. But before I do that, I can check that if already the total property, or like the remainder, is 0, then I don't need to delete nothing, because the sum of the complete nums vector achieves the condition that is divisible by p. In that way I will return 0. Then if this is not the case, I will need to use my custom logic. Also, another important thing is that because I will start like with the first element directly, that means that before starting I had 0 of, let's say, remainder, and I am going to use the less one, because it's usually the vectors are indexed 0 based. But if I am assuming that I have already started with 0 as property, it will be in the previous index before starting to traverse the vector. Then I can start again to iterate against the numbers, and I need to perform the calculation of this, let's say, current property in order to store it in the property prefix unordered map. Let's call it current property. That basically will be the property until the current index. Also, I will need the length of the nums. Current property 0. Then current property will be calculated in this same way, applying the same property. Okay, then I need to store the current property in my property prefix unordered map, and I am going to store the index. In this way I can ensure that for each, let's say, previous value, I am updating the closest index that achieved this condition. For instance, I will store in my property prefix unordered map the closest E for each J, because I am iterating for E increasingly. Okay, then I need to check like for a possible value of the starting of the subarray. For that, I will need to perform some subtraction. Let's call it like, first we need to find the value of y minus x in order to search for g according to this equation, and then let's call it searched plus property will be equal to current property minus total property, and this mod p. But also, if after performing this calculation this is less than 0, because I am working with positive, let's say, reminders, I will increase or sum the same value of p, because in this way I won't change the reminder. I will only turn this into a positive element. Then I need to also, I didn't initialize the answer. Let's initialize it as <1 and also return it here. And if, let's say, if this searched pass property, we need to check if this searched pass property exists in our property prefix, let's say, unordered map. Then if so, first we need to check if answer is still initialized, then we can directly assign the value of E less is the current index, and then J will be the value that is storing in our property prefix unordered map. And if not, Also, we can store this into a variable in order to not repeat. If answer is already initialized, that means that the value is different than -1, sorry. We need to check between the previous value of answer and the new value of answer, which is the lowest, shortest value, because we are asked to minimize answer. Another thing that we need to check is that this idea behind using property prefix in order map does not validate or doesn't validate for the current element. For instance, let's assume that we are finding for a superarray which reminder is 4, and the current element has the same reminder 4. We can only delete the current element, and then that will be the answer, because only deleting a single element could achieve us to follow the condition asked for the problem. For that reason, we need to check if e mod p equals to total property. Then we know that the answer is 1, and then we can break because there is nothing less than 1, and for the 0 case it's already filtered here. Okay, let's see if this works. 1, 2, 0. Okay. Let's send it. Also I forgot another thing, is that the problem is asking us to check it is not allowed to delete the complete array. For that reason, we need to check that if let's store this also into a variable, current subarray length if current subarray length is equal to the length of the complete nums vector, then we basically we need to skip this, because it is not let's say valid to do this. Let's copy only this part. Okay, then let's submit. Okay, I hope that the explanation was clear. If not, let me know. Thank you.